Hello guys, welcome back to Maths Zone African Motives. Still on our mathematics N6 and still on our differentiation. That is continuation on our partial derivatives. Like I said before, questions can differ with the type or with the scenario that you're given, the situation that you're given there. It differs. The situation that you're given, you work with that situation. But the idea is not changing. All right? The idea is not changing. What am I trying to say? The idea of the partial derivatives is not going to change. So as we understand the quotient rule from our N5, even N4, we talked about this, the derivative whereby you consider to be taken from a fraction u over v as a function of x, and this v also as a function of x. We can actually differentiate anything of this nature from our formula. That is v, the first derivative of u, minus u, the first derivative of v, all over v squared. All right. With the formula, it's fine, but where do we apply the scenario where, let us take a consideration that we are given z that is equal to 3x minus 2y. All right, over x plus 2y. Okay, remember our partial derivatives, guys, we've got z given in terms of two variables at the same time. And you are asked to differentiate, let's say we are given this is what you are given, and you are asked to find the first one. You're going to have the derivative of z with respect to x. And also the derivative of z with respect to y. So if we were to consider finding the derivative of z with respect to x, what were you going to consider? Like I said before, is that one variable is worked with, another one taken as a constant. At this moment, I'm working with respect to x. So what does it mean? It means another variable, which is the other variable there is what? It's y. This is the other variable that we can see properly that there is a y there. Okay? It is going to be considered as a constant, which is fine. So y is a constant. That's it. Okay. Now let's do this. We want to differentiate with respect to x, and y is a constant. We're just going to close where there is y, there's a constant. Where there is y here, there's a constant. So there's a function here of x, because this is 3x minus like a number, like just 3x minus 2, like that. 3x minus 2. It can be x plus 3 over x plus 3. So because we are considering this as a constant, so you can see that in order for you to differentiate this, you will need to have your quotient rule, because this is considered as a function of x. At this moment, this also as a function of x. So from our formula, we are saying that the derivative of this nature is going to be v, right? Which is here, this is our u, this is our v. So v, we're just taking our v as it is. That's x plus y, okay? Times the first derivative in terms of our u, this is our u in this case, which is 3x minus 2y. We are supposed to differentiate this with respect to what? To x, take note. So we are going to differentiate this x, which is 3x. What is the derivative? We're going to get 3. Okay? We move on to the minus 2y. Minus 2y. 2y. Where we said y is a constant. So what do you get from a constant, guys? A 0. That's a 0. The derivative of a constant. This is just same as 3x minus 7. 3x minus 20. 3x minus 100, whatever number that you get here, it's a constant. The derivative of that is going to give us a 0. So this is simply 3 minus what? 3 minus 0. The derivative of a constant is a 0, like I said. All right. So that is where we are. Minus. So you're going to have minus u. Going to take our u as it is. that is 3x minus 2y, times the first derivative of our v, which is x plus 2y. So we're back again to the derivative of this, x plus 2y, with respect to x. So we want the derivative here with respect to x. So meaning to say the derivative here of x, that's a 1. So we're going to get a 1 plus the derivative of 2y with respect to x, y is a constant. So the derivative of 2y is going to give us a 0, just like the derivative of 100, derivative of 1000, that's a 0. All right, everything over what? So this is what we have here. Everything over v squared. Our v, which is this part, x plus 2y, that's our v, so it's going to be x plus 2y squared. So that's it. We can simplify further, but that's the whole idea, guys, that you just need one. Consider what are you differentiating with respect to is very, very important as you are using whatever method that you're going to use, but what are you differentiating with respect to? All right. So that's it. 3 minus 0 there, that's a 3. So it's going to be 3 into the bracket of x plus y. All right, that will be x plus y. Okay, sorry for that. Then here 1 plus a 0 there, that's a 1. So it's going to be minus 1 into the bracket of 3x minus 2y like this. Everything over this bracket squared. Everything over x plus 2y squared. Okay, so that's it. So you can simplify, expand the brackets. Definitely, they're going to need to expand the brackets by 3. 3 times x here. That will be 3x, 3 times y. That will be 3y. Minus 1 times 3x. That will be minus 3x. Minus 1 times minus 2y. That will be a positive there. All right. So this is it. Everything over x plus 2y squared. So that's what you're going to have. And what you need is to simplify properly everything so that you obtain your final answers. That's 3x here minus 3x. So that's a 0 there. 3y plus 2y. So if we add, this will give us what? A positive 5, right? Okay, I'm gonna check something here, guys. Let me check something. All right, I thought I had a 2 there. This is x plus 2y. Yeah, I had a 2 here on my v. Sorry for this, guys. You check here our v. Okay, the v there. This is vx plus 2y. Let's just correct this. X plus 2y here. All right, that's it. So this will be x plus, if you multiply, this will be a 6 there. Very sorry for this. So that will be a plus 3 times 2, which is 6y. All right, yes. So there we are. Like I said, 3x minus 3x there, that's a 0. So you're gonna have 6y plus 2, which is 8. So this is going to give us 8y over x plus 2y squared. Okay, so this is the derivative of z with respect to x. So you just need to be careful, all right, in your simplification, the formulas and so forth, and your application of the formulas. All right, so like I said here, this is our v, this one. That was our v, it's x plus 2y, not x plus y, x plus 2y. It was just a mistake on taking up this. So that was the derivative of z with respect to x. We could have, we applied, I mean, in this case, the quotient rule in order for us to simplify this, which is the same situation. Maybe it might differ in terms of another variable. So we have to check according to the question. Let's check if we can also have the same scenario in determining of the derivative of z with respect to y. Are we going to have the same thing on this part? Are we going to have the same thing? That is the question. All right, let's see. If we are differentiating z with respect to y, it means at this moment, x is our constant as usual. So if we close the part of x, it means there's a constant here. So there's a f of y, there is a g of y, another function of y there. So meaning to say this is a quotient rule. We've got y on top, we've got also y in the denominator. So we are going to use our quotient rule again. So we said on our quotient rule, you're going to have v, the v as it is, which is the v in this case, that's x plus 2y. That's our v. Times the first derivative of u, but with respect to y. This is our u in this case, which is 3x minus 2y. We have to differentiate this with respect to y. So if we differentiate this with respect to y, what does it mean? This x, remember we said it's a constant. So the derivative of a constant is going to give us a 0. That's a 0 there. Minus the derivative, we are focusing on y. So there we have to find the derivative. What is the derivative of minus 2y? So that will be a negative 2 in this case, all right? So that's 0 minus 2, okay? So we consider y at that moment, okay? Plus, minus there, so you're going to have minus u, our u in this case, which is the whole of this part. So that is 3x minus 2y like this. That's our u times the first derivative of v. This is our v, which is given as what? Our v is given as x plus y, x plus 3y, okay? So meaning to say, we are supposed to find the derivative with respect to y. From this v that we are given, this our v, which is x plus 2y. So we are differentiating with respect to y there. So what is the derivative? Okay, let us see. Okay, x is a constant. Remember, x is a constant. So the derivative of a constant gives us a 0. So that's 0 plus the derivative of 2y, which is going to be 2, because it's with respect to y. So that's what you're going to have. And do not forget to divide, okay? So you're going to have everything over v squared from our formula. That's v squared here. So you're going to divide by v squared, which is x plus 2y squared. All right, so that's it. That will be the derivative of z with respect to y. 0 minus 2, that's minus 2. So it's minus 2 into the bracket of x plus 2y. 0 plus 2, that's a 2. Then negative times 2, that will be negative 2 into the bracket of 3x minus 2y. Okay? Everything over v squared. So this whole part here, going to take this everything over v squared, which is x plus 2y squared, like this. Okay, so that's it. We can simplify further. The derivative of z with respect to y is going to be negative 2 times x. That's negative 2x. Negative 2 times y there, which is negative 4y. Negative 2 times 3x, that's negative 6x. Negative, here, that will be a positive 4y. Okay, that's it. All right, everything over. Do not forget that we've got x over 2y squared as our denominator in this case. Okay, so here we can try to combine our terms and see what we are going to have at the end. That's minus 4y here, and 4y will cancel, okay? As you can see, these two are the same. So we are left with negative 2x, negative 6x. Negative 2, negative 6, that's negative 8. So it will be negative 8x over x plus 2y squared. X plus 2y squared, like this. So that's what you're going to have at the end. So as you can see, it's a simple scenario, a simple situation that you just need to understand where you're coming from in terms of your derivatives, okay? So I'd like you guys to work on the quotient rule. As usual, from our N4, we talked about the quotient rule. N5, we also had questions which needed us to use the quotient rule. So it's very, very important. One, you understand the concept. Where exactly am I applying the quotient rule? It's a division. But is it a division of both functions to be considered of x? Because if I am given something like this, I want you to see this. Let's say z is given as, I'm just going to take any function of my choice. Let's say I've got a cos. All right, I've got cos in this case. This is cos x y like this. We've got cos xy, everything over y to the exponent of 3. All right. I want you to see here, guys, be very, very, very careful. Very, very careful. Okay, let us start with x. On this z that we are given here, all right, this is what we are given on this part. And you'll be asked to find or to determine the derivative of z with respect to x, and also maybe the derivative of z with respect to y. This is what you might be given in these conditions. Okay, sorry. Why am I saying so? Why am I saying you have to be careful? If you check, or if you take a closer look here, on the derivative of z with respect to x, this is what we have. All right, that's our first part here. I have the derivative of z with respect to x. Remember what I said? Y is going to be considered as a constant. Okay, y here is a constant, y here is a constant. So what does it mean? This is not we are not using any quotient there, because we can see the only function of x, okay? So meaning to say, this is treated as the whole of it as a function of x, because y is a constant here, y is a constant. What does it mean, guys? It's like this. Let's say y is 2, okay? Y is 2. So this is same like we are given this as cos 2x, like this, over 2 to the exponent of 3 is 8, like this. Because y is a number, it's a constant. This is what it means. How do you differentiate cos 2x over 8? You just have to take this out, okay? It becomes a negative on this part, side cos changes to sign. But it's, do you use a quotient rule on this question because it's a fraction? No. It's a fraction, yes, but you don't use a quotient because this is a constant. If it was a function of x like 8x like this, now we are forced to use the quotient rule, because this is a function of x and this is also a function of x. There we are now forced to apply our quotient rule. But this is just a constant, just a number 8. It's just like we're given to differentiate x cubed over 9. Do you use quotient rule like this? No. It's a term. This one is, I mean, it's a number, it's a numerical. You don't do that. So this is what is happening on this y. Because y is a constant, we are not going to focus on this. So the derivative of z with respect to x on this one is direct. So how do you differentiate cos? Remember, cos changes to sine. So it's going to be negative sign. And like I said, if it is cos 2x like this, you take this number out. So this is the same thing. Y is representing our number, just like what? Just like 2. So it's going to be minus y, the sign of xy like this, over y cubed, because y is a constant, just like cos 2x over 8. You differentiate cos 2x, you get negative 2 sine of 2x like this over 8. 8 is not affected, just the same thing as y cubed, because y at this moment is a constant. So if y is a constant, it means we are not focusing on it. It's not like an addition where we are given maybe x squared plus y cubed, where we differentiate this, we differentiate this. This is on a single term, all right? It's on a term. So you don't differentiate that. You differentiate with respect to x. So, but you can even simplify further y and y cubed, that will be y squared. There are 2 that will remain. So that will be minus the sine of xy like this over y squared. Okay. But let's check the second one. Like I said, you just have to be careful. The second one, we need to find the derivative of z with respect to y. Okay. This is what is happening this time. When we are finding this with respect to y, it means X is now a constant. This is what we agreed. X is now a constant. So if X is a constant here, it's like just like there's a number there, like 2, just like the previous part. So it's just like cos 2y like this over y to the exponent of 3, because X is now our constant. So what does it mean? In order for us to differentiate, this one is now a quotient because we are considering 2y. There is a function of y. The top part, it's a function of y, this one. The denominator is also a function of y. Because here it was just x considered. Because y was a constant, so we just left with x. It was just a single term. But this one now, as we remove x, this is a function of y. This also is a function of y. So this one, it needs us to apply the quotient rule because we are dividing two functions of y. Take note, because it's no longer y is not a constant this time. Last time it was a constant. It was taken as a number. That's why we didn't even mention about this. We just rewrote as it is. We just rewrite as it because it's a number. It was a number last time. Y was just a numerical value, a constant. But this time, that is our variable that we want. So it's like we have a variable of y in the denominator. So we have to apply the quotient rule on this one. All right. So it's not like always you apply the quotient rule. Some questions, they do not need quotient rule. Some they need. So like this one, it's a fraction of y. So that's why we have to apply the quotient rule. Remember from our quotient rule, said if we can write this in terms of u over v, the derivative of this will be taken as u, that will be v, first derivative of u, minus, we're gonna have our u, the first derivative of v over v squared. So that's it in this case, meaning to say our u and v from the concept that we have of a fraction, this is our u, this is our v. So we need v first. Our v, which is the denominator as it is, that's y to the exponent of 3 times the derivative of u. Our u in this case is cos. We are differentiating cos with respect to what? To y. So this is what is happening. We are differentiating with respect to y, the cos of xy. So remember, cos changes to sine. So it's going to be a negative. X, remember, it's a constant. So it will be negative x. Just like cos 2y like this. It's negative 2 sine 2y. You take the constant out. So it's the same thing. Our x is a constant. We take it out. So it's going to be negative x, the sine of xy. All right. We have differentiated u minus u, we take our u as it is, which is the cos of xy, as it is, okay? Then we move on to the derivative of v. This is our v, which is y to the exponent of 3. We just have to drop the exponent. So that will be 3y squared. We subtract 1. Remember, drop the exponent, then we subtract 1. So it's going to be 3y squared. All right, that's it. Everything over what? Over v squared, of which our v as the denominator, that's y to the exponent of 3 to the exponent of 2. That's it. So you see the difference that we have between these two questions. This one for x did not need, there was no need for us to use the quotient rule. It was a direct thing. But this one for y is not like that because we have got two variables of y, two terms in the numerator, in the denominator. So that makes it to be a quotient. All right. So let's multiply and simplify. This will be minus x y cubed, the sine of xy. So let us just write the sine of xy in a bracket like this. All right. Minus, we can start with this because it's not part of our cos. So that's minus 3y squared. The cos of what? The cos of xy. All right, everything over this to the exponent of 12, which you can raise. Remember, an exponent and an exponent, they multiply each other. So that's 3 times 2, which is 6. So that can be written as y to the over y to the exponent of 6. So that's it. The second one, it needed us to use the quotient rule. The first one, there was no need for us to use the quotient rule. So those are the typical questions that you have to expect in your syllabus, and also the part of the chain rule, but the chain rule is just a direct application, because as we are differentiating cos xy, we are actually using the chain rule if you see that. So we're not going to talk about that, but the major part is this one that we have and that we've talked about. So I want you to go through, if you have not watched the introduction, and also not, if you have not watched the other part of the product rule, make sure that you do so that you understand the basics of what you are working with, and also the introduction as a whole on what exactly are we talking about. And also join the membership. By joining the membership, you've got unlimited access to whatever question that you want us to work on. If you have got a question pertaining the syllabus of Mathematics N6, you can just ask the question so that we can work on that question together. That is a membership token given to you guys. Okay, anyways, more to come from Mason African Motives.